Hello, this is Jean-Charles Bagneris, and this screencast is about time value of money. In this first part, we will deal only with present and future value calculations. In addition, all the calculations we will do here will be based on interest compounding. We will start by doing the three exercises here and using the formulas you can find here on the cheat sheet. And in this formulas here you have time value of money, present value, future value, and in this column the necessary formulas for compound interest. So we will use these two basic formulas. The first one gives the present value we call C0 because it's the cash flow you get in time zero, and we have C0 depending on Cn, the cash flow you will get in year n. It's a future value. And here the opposite, the future value given the present value. Now let's start with the first exercise. What is the present value of a 15,000 euro cash flow to be paid in 10 years if the discount rate is 4.6%? So here clearly we are asked about the present value. Then we use this formula. We are looking for C0 and we know Cn, actually this is C10, the cash flow you will get in year 10. Then let's use the formula again. You take the future value C10 over 1 plus rate to the power of the number of years. So here you get 9,566 point something. Notice that you can get exactly the same result by doing the calculation this way. Again, the future value times 1 plus rate to the power of minus the number of years. And again, you get the same result. Thus, either you divide by 1 plus rate to the power of number of years, or you multiply by 1 plus rate to the power of minus the number of years. Now let's try the second one. A 3,000 euro deposit is made on a savings account paying 2.8% per year. What is the future value after 5 years? Then here we know the present value of the deposit because we deposit the money now, so it's 3,000. The number of years is 5 years and the rate 2.8%. And we are looking for the future value in year 5, which is C5. Then C5 is given by this formula, future value given the present value. So we multiply by 1 plus rate the power of number of years. So C5 is C0, present value, times 1 plus rate to the power of number of years. And here's the result. So far it was quite simple. Just go from present value to future value or from future value to present value. Now look at the third one. What is the necessary interest rate to double a deposit after 10 years? So here we don't know about the present value of the future value. We only know that we want to double the present value. That means that the information we have is first the number of years is 10 years, and what we want to achieve after 10 years is C10 over C0 is 2, because we double the amount. Now how to get the rate to have this result? Look here. We use again the formula of the relationship between future and present value. Okay, let's put it this way, and then from this relationship we get the ratio of future to present value. Just take C0 and put it on this side. Okay. Then we have 1 plus rate to the power of number of years is equal to the ratio. Take the power, put it on the other side. That means 1 plus rate is ratio to the power of 1 over n. And finally, rate is ratio to the power of 1 over n minus 1. And we will use this formula. Now let's apply our formula. Then we have the ratio to the power of 1 over number of years minus 1. It gives 7.18%. Finally, in the first exercise, we had the future value. We are looking for the present value. In the second one, we had the present value and we are looking for the future value. And finally, in the third one, we had a relationship of the future value to the present value, and we were looking for the rate. I think that's enough for this first screencast. Thank you for your attention. Goodbye.